Hey guys, today we are looking at 6.10, which is going to be trigonometric integrals. So we're looking at some trig integrals. So as a refresher, let's remember our trig derivatives. So the derivative of sine of x is going to be cosine x. The derivative of cosine is negative sine x. The derivative of secant is secant x tangent x. The derivative of cosecant is a negative cosecant x cotangent x. The derivative of tangent is secant squared x. And the derivative of cotangent is cosecant squared x with a negative in front of it. So something to kind of help you remember, all of the so cosine, cosecant, cotangent functions are going to have a negative in front of them. And then sine and cosine are just the opposite of each other. Secant and cosecant kind of follow the same. So secant is secant tangent, cosecant is cosecant cotangent, and then our tangent is secant squared and our cotangent is cosecant squared. So they kind of follow some patterns there that you can see to help you remember those. But now let's talk about the other way around. So our trig integrals. So if I'm trying to find the integral for cosine x, that's just going to be sine x plus c. The integral for a negative sine x would be cosine x plus c. Our secant tangent, the integral would be secant x plus c. Negative cosecant x cotangent x, our integral would be cosecant x plus c. Secant squared x, our integral would be tangent x plus c. And a negative cosecant squared, the integral for that one is cotangent x plus c. So it's just our derivatives backwards. I will tell you that a lot of time these negatives are not there. So a lot of times it'll ask you, okay, what's the integral of sine? So if you're looking at that, the integral of sine, you would have to put the negative when you take the integral, so it would be negative cosine. And I believe we talked about that in a previous set of notes, but just a heads up that those negatives aren't always there. So if the negative is missing, you need to make sure you put the negative when you take the integral. All right, let's look at some examples here. So the first thing that we are going to look at is this over here. So I have the integral of cosine ax over dx, and I'm going to tell you that the formula for that, if I'm trying to take the integral of cosine ax, it's going to be sine ax over a plus c. And so the reason that we do that, well, let's consider taking the derivative of sine of 2x. We're going to have to do the chain rule where the outside is the sine and the inside is the 2x. So the derivative of the sine would be cosine of 2x, and then we would multiply it by the derivative of the inside, which is our 2x, and the derivative of that would be 2. So we'd end up with 2 cosine 2x. So we're kind of going backwards from that. So if I have something on the inside of the trig function with my x, when I do an integral, I also have to divide by whatever that is. So when integrating, we can take care of the chain rule from the derivative by dividing by the number plugged in with the x to the trig function. So that's that formula right there. So number one right here, we have the integral of negative 5 sine x dx. So if I'm looking at my negative sign right here, the integral of that is cosine. I've got a 5, so this is going to be 5 cosine x plus c. Looking at number 2, let's switch colors. Number 2, I have a negative 2 over secant x. Well, if I have 1 over secant x or negative 2 over secant x, that's the same thing as saying the integral of negative 2 cosine x dx, because secant is 1 over cosine. So 1 over secant would just get me back to my cosine. And up here, our integral of cosine is sine. I have a negative 2 in front of it, so it's just going to be a negative 2 sine x plus c. All right, number 3, we've got a negative 2 cosine x. That's the same integral that we just took, but now we have bounds. We're going from pi over 4 to pi. So -2 cosine x, our integral is -2 sine x, and we're going to go from pi over 4 to pi. So what that means is I'm going to plug in my pi, so -2 sine of pi, and I'm going to subtract from it, plugging in that pi over 4, so -2 sine of pi over 4. So sine of pi is 0, so I have -2 times 0, minus -2, and sine of pi over 4 is going to be a square root 2 over 2. So this just goes away. So I'm looking at negative -2 square root of 2 over 2. So those negatives cancel out and those 2's cancel out. So I'm just left with the square root of 2. All right, looking at number 4 is when we're going to use this rule that we just did right there. I've got a secant squared of 2x. So if I'm looking at the integral of secant squared, that integral is going to be tangent, but I have a 2x. So when I take my integral here, it's going to be tangent of 2x divided by 2, because there's a 2 inside with that x. And then we are going from pi over 4 to 3 pi over 4. So I'm going to have the tangent of 2 times 3 pi over 4 all over 2 minus the tangent of 2 times pi over 4 all over 2. So we can simplify that down. Instead of writing it over 2, I'm going to write it as 1/2. So I'm going to have 1/2 tangent. The 2 times 3 pi over 4 is going to change it so that it is 3 pi over 2 minus a 1/2 tangent. Right here, the 2 over 4 means I'm just looking at pi over 2. And my tangent for 3 pi over 2 and pi over 2, both of those are undefined. So my answer here is just going to be undefined, because the tangent of 3 pi over 2 is undefined and the tangent of pi over 2 is undefined. So it is possible to take an integral and end up with undefined as an answer. All right, number 5, we are looking at secant 4x, tangent 4x. So secant tangent means that my integral is just secant, but because we have that 4x, it's going to be secant 4x divided by 4, and we're going from negative pi over 16 to 0. So what that means I'm looking at is the secant of 4 times 0 over 4 minus the secant of 4 times that negative pi over 16 all over 4. So I'm going to have a 1/4, bringing that in front, secant of 0 minus 1/4 secant. And if I have 4 times negative pi over 16, that's going to simplify to negative pi over 4. And using some of our trig, secant is 1 over cosine. So if I'm looking at cosine of 0, that's 1. So 1 over 1 is still 1. So I'm going to have 1/4 times 1. And then cosine of a negative pi over 4 would be, what is that, root 2 over 2. So then the secant would just end up being a square root of 2. So minus 1/4 square root of 2. So this simplifies down to 1/4 minus square root of 2 over 4. Got to remember all of that trig. Sometimes I forget it, but you have to remember it for the AP test. All right, so now let's look at some inverse trig derivatives. So if we're talking about inverse, remember that it can also be written as like arc sine instead of sine to the -1. So make sure you know, like on the multiple choice section of the AP test, that it could look like either of those. And then there's a memory trick over here. So S function, so sine or secant, means that you're subtracting and there's a square root. So sine, I've got a square root and I'm subtracting. Secant, I've got a square root and I'm subtracting. For the sine, the 1 comes first. So we've got 1 minus x squared for secant, it's x squared minus 1. And then the co-versions, it's always basically the negative of what you're starting with. So another thing that could help you remember this, it's not written there, but our secant has the absolute value and our tangent doesn't have anything with it. It doesn't have a square root or an absolute value. And then all of your co-functions, cosine, cosecant, cotangent, are basically just the negative versions of the exact same thing. So really you only need to memorize 3, and then the other 3 are just the negative version of it. Okay, so taking the integral is just the antiderivative. So now we're just going to go in the other direction. So if I'm looking right here, I've got a negative, so that means I'm looking at cosine, cosecant, or cotangent. It's got a square root, so it's not going to be cotangent, but it doesn't have an absolute value, so it's not going to be cosecant. So this one is just going to be cosine. So I'm going to write it as cosine to the negative 1 of x. Oh, you don't need the parentheses. And then put a plus c. Also, alternatively, you could pull the negative out. So then I just have the integral of 1 over the square root of 1 minus x squared dx. And that would be negative inverse sine of x plus c. So it technically could be either of those. All right, 7. We've got a negative, so that means I'm looking at one of my co-functions. And I've got an absolute value right there, so that means that I'm looking at cosecant. Inverse cosecant of x plus c. Or we could do the same thing that we did on 6. We could take that negative out. So then it would be negative integral of 1 over the absolute value of x, square root of x squared minus 1 dx. And that would then give us our negative inverse secant of x. So it technically could be either of those answers. Okay, so now we're going to look at 2 more, and these are a little bit different. So notice that we don't have 1 over. Like up here, all of these are 1 over whatever's in the denominator, but now I have a 3 on top. So first thing, I'm going to try and figure out which function we're looking at here. So there's no negative, so that means it's sine, secant, or tangent. And there's no square root or absolute value, so that means that we're looking at our inverse tangent. So I know that I'm going to have an inverse tangent. But now we need to talk about what's going to be inside that inverse tangent. So if we're talking about a derivative, let's look at our derivative of our inverse tangent. And right here, I've got a 9x squared. So normally it's just x squared. But now that I have a 9x squared, that means I'm really looking at 3x quantity squared. So let's think back to our derivatives. If I was taking the derivative of my inverse tangent that had a 3x inside of it, then that means that I would have to use the chain rule. So my chain rule, I would take that inverse tangent, and the derivative of the inverse tangent is 1 over whatever is inside the tangent, so 3x squared, and then plus 1. And then I'd multiply it by the derivative of that inside, which the derivative of 3x is just 3. So cleaning that up, I could put the 3 on top of the fraction, and then 3x squared would be a 9x squared plus 1. And that gets us back to what's inside of our integral. So we're kind of looking at doing the chain rule backwards. So my answer is going to be inverse tangent, but it's going to be inverse tangent as 3x plus c. So we're kind of looking at the chain rule backwards. So let's use that same reasoning to look at number 9 right here. So first of all, let's figure out which function we're looking at. There's no negative, so it's going to be sine, secant, or tangent. It's got a square root, so it's not going to be tangent, but it doesn't have an absolute value in front of it, so it's not going to be secant, which means we're looking at our inverse sign. And now we need to figure out what's going to go inside of that function. So to do that, I'm going to look at my 25x to the 8th. So it's normally whatever is inside of my tangent squared. So that's normally an x squared. So if I have 25x to the 8th, well, that's the same thing as 5x to the 4th squared. So let's come and check with our derivative. So if I'm trying to take the derivative of an inverse sine of 5x to the 4th, normally it would be 1 over the square root of 1 minus my inside squared, so 5x to the 4th squared. And then I need to multiply by that inside using our chain rule. So the 4 would come down and we'd get a 20x cubed, which matches what's on top of our fraction here. So simplifying this over here, I would have a 20x cubed over the square root of 1 minus, and I can distribute that squared and get a 25x to the 8th. So that kind of works out that we're doing it backwards with our chain rule. So our answer here would be the inverse sine of 5x to the 4th, and then put a plus c right there. Oh, let's draw that where it's not going through the answer. So when it doesn't necessarily look like the ones at the top here, when you've got some extra numbers in there, you need to start thinking about, okay, how would I do the chain rule backwards? And we are going to talk a lot more about that in our next set of notes. But for right now, that's it for this set of notes. So you do have a Go formative that goes with this. Make sure you are completing that. And then if you have any questions, you can ask me in class, come to my tutoring times, or shoot me an email. So make sure you get started on that Go formative, and you guys have a good day.